Hello, everyone. I'm Rod Dayrit, Global Director of Business Development at Delta Q Technologies and the Zappi Group. I'd like to welcome you to this session. Couple things. Please remember that this session is being recorded and it will be available to watch on demand following the session. If you have any questions during the session, please add them to the Q&A section on the top right. Note that the questions will be sent privately, but if the speaker deems necessary, he will answer the question during his session. With that, I'd like to introduce you to our speaker. I'd like to welcome Robert Kang, co-founder and CEO of Blue Whale Materials, who will be speaking to you today about a very important topic in our industry, lithium battery recycling. Welcome, Robert. Take it away.
Thanks so much, Rod. Thank you, everyone, for joining us here. I appreciate the opportunity to share with you about the future of lithium-ion battery recycling, which is vital to create a sustainable world for all of us to live in. I'd like to start by just giving you a brief overview of our company. As Rod mentioned, I co-founded the company with David Favre back in 2015. We really began in our company by exporting and brokering batteries from the U.S., about 4 million pounds of spent lithium-ion materials, batteries from the U.S. to South Korea for recycling. In 2017, a CTO joined us from Sungyeol High-Tech, which is one of the largest hydrometallurgical refiners in the world, focusing on lithium-ion battery recycling. He joined us, came up with a proprietary technology, which we validated at scale, commercial scale, in 2019, and eventually brought it to the U.S. And we filed a patent for that, and it's currently patent pending. We raised about $80 million for investment in 2022. We are currently building out our first facility, which I'll share with you, will be operational at the end of 2024. And we also bought a testing and evaluation company that provides third-party certification for new batteries and technologies that comes online. Blue Whale Materials, our mission is very simple: to provide lithium-ion battery recycling solutions to safely reclaim and responsibly supply valuable critical minerals like cobalt, nickel, and lithium for the growing electrified economy. I think everyone understands today that lithium-ion batteries are penetrating every aspect of life. It's estimated that in 2030, there will be 1.5 million EVs projected to reach end of life in that time. And with all of the other batteries that will be coming offline, there are estimations that there will be over 2.8 million metric tons of batteries available for recycling. Now you look at 2040 and you see that number skyrockets to 31 million metric tons of available lithium-ion batteries that must be recycled and properly processed globally. Oh, sorry. And now when you think about this huge volume of batteries that are available and need to be recycled, it's estimated today that about 2 to 5% of the world's lithium-ion batteries are currently being recycled. That number needs to increase exponentially. And if we're unable to increase that number by not recycling, we are creating an environmental, a national security, and electrification concerns for our future. Environmentally, we must eliminate the risks of a thermal event that all of these batteries contain. Even without, I think it's so misunderstood that batteries that are not even powered, have no electricity in them, are still have a risk of a thermal runaway event. You fill our landfills and you can imagine that they can combust at any time as batteries over the use and over their lifetime become more and more unstable. This is becoming a national security issue, whereas, as I'll share in the next slide, foreign entities, foreign powers, countries control most of the supply chain of these batteries that are critical in electrifying the future. And so in order for the US to engage and to be prominent in this electrification, we must start to secure these batteries for domestic use. Of the batteries that are currently available to be recycled, 9.2% of end-of-life lithium-ion batteries are processed here domestically. But as they're processed, they are then exported to China for the continued work of metal recovery that's due to the lack of capacity here in the US. 44.5% of the estimated end-of-life lithium-ion batteries were exported to China and then others to rest of the parts of the world to be processed. This number must change in order for us to become, again, a competitive and begin to have a presence in the electrification economy. We must change this amount as we move forward. And again, this slide shares with you that it's not only about recycling, but it's the whole supply chain of these critical minerals that go into the electrification economy that, especially you see here, China controls mostly about 80 to 90% of the total life cycle of a battery, from the mining of materials to the chemical processing, the refining of the mined material, then the production of the cathode and anode material that goes into a battery, and then eventually the cell manufacturing that occurs, all occurs abroad in China, an issue that we must address significantly. This slide shows you the lithium-ion battery recycling capacity currently today in the US and the rest of the world, and as opposed to what will be, this happened in 2010 versus what is available today. And as you see, recycling methods predominantly occur abroad, which again, we must change. I wanted to highlight just the 3 types of recycling that occurs today. There is pyrometallurgical recycling, hydrometallurgical refining, as direct recycling, and I want to address each of those to share with you all. Pyrometallurgical recycling, as the name suggests, basically you are smelting these batteries at very high temperatures to be able to separate the metals from one another from different critical melting temperatures. And so, as you can imagine, with the high heat and smelting, you're producing a significant amount of emissions, and the carbon footprint is something that the industry would like to get away from. And that's where hydrometallurgical refining comes in. Hydrometallurgical processing is basically the chemical leaching solvent extraction process that is the refining method of choice today and in the future, because it is very low energy intensity, as well as the reduced carbon footprint when you compare it to pyrometallurgical refining. And then finally, direct recycling. Direct recycling is an innovative approach to simply extracting the cathode active material within a battery, not having to go as pyro and hydro does to separate the metals from one another, but just takes that active material from a battery, recycles it so that it can be put into new batteries. This is in pilot scale. There are many companies that are trying to go after this process, and as you can imagine, in doing so, you eliminate the multiple steps required to recycle this material. It's in pilot stage, and we hope that this kind of technology will come to fruition and be adopted in the future. When you think about these three types of processing and refining, there are benefits and drawbacks to each of them. Pyro, again, the carbon footprint, the energy consumption needed to reach those high temperatures to melt and extract those metals from one another. The hydro, it is very significant amounts of chemicals are needed to extract these metals. And so the operating costs, capital costs are very extensive and very expensive. And then direct recycling, obviously those that minimizes these steps so that active material can be recycled, but again, are all in pilot stage. What I'd like to point out is for whether you are using pyro recycling, hydro recycling, or direct recycling, all of these methods go through a pre-processing process that's critical to preparing the metals for the recycling process. And there's different ways of this pre-processing that takes place, which we'll get into a little bit. But primarily today, there's water leaching, water discharging, where the batteries are basically just put into a submerged in saline solution or water to slowly discharge the battery and prepare them for processing, or using nitrogen. And so these methods are used simply to ensure that that thermal event where these batteries are volatile can be neutralized and eliminated, so then we can begin the process of shredding and preparing the material to be recycled. When you think about this and you think about all of the announcements that we hear of battery manufacturing plants, these gigafactories that are coming online in the US, you really think about the need of materials to support the battery manufacturing. So today, it's estimated that there will be over 1.3 terawatt hours of batteries manufactured in the US by 2030. Multiple gigafactories that will be coming online. In order to feed those factories and produce those batteries, there will be a significant uptick in demand for the materials that are necessary. So you see here in 2022, globally, lithium, about 678,000 tons of lithium was produced and mined globally. In 2035, we will need over 4 million tons of lithium to meet the demands and the projections that we see of battery manufacturing to take place. Cobalt, 177,000 tons in 22. In 2035, over 3 to 4 times that amount. Nickel at 3,160,000 tons. In 2035, will almost double the amount of carbon will almost quadruple to meet the demands that we are projecting of battery manufacturing to take place. So as I said, and as we can imagine, recycling would become a key aspect of trying to meet some of those demands and take away from the mining that is needed to address this material shortage. And in those 3 different types of recycling processes I mentioned, they all have a common beginning, and that is pre-processing. Basically, pre-processing takes place where a battery is discharged, it's shredded and mechanically separated from the plastics, the aluminum, the copper, from those precious metals of lithium, cobalt, nickel, and manganese. That concentration of metals is referred to in our industry as black mass or black sand. And this is that recycled metal mixture that's produced, which is then sold on to refiners like pyro, hydro, or direct recyclers that are able to extract the metals from one another and put them back into manufacturing new batteries. Battery chemistry determines the types of and amounts of metals. Chemistries are changing continuously as different OEMs and battery manufacturers are trying to find the most density that they can get out of these batteries. Everyone's talking about how long your battery will last, how much power it holds. So as chemistries are changed to provide a further and provide more density in these batteries, the processing methods will remain, and that's where we see the concentration of metals that come out. As these recycling capabilities come online in the US, I think there are some significant barriers to the industry as it begins here in the US. There's a lack of infrastructure. Very frankly speaking, we are a country of consumers. We think very little of recycling, and we produce, as we consume, we manufacture a lot of waste. Unfortunately, that infrastructure will need to be increased and established in the US to collect these batteries and bring them to recycling solutions. In order to collect these batteries, we'll have to provide the logistics. The United States, very big geographic footprint. We are a large country. So you can imagine taking an end-of-life battery from Maine and bringing it to a facility in Oklahoma, for example. Those are significant logistics costs in transportation. So it's estimated today that over 41% of the total cost of recycling is simply the expense of moving and collecting those batteries from one point to the recycling solution. There's a lot of regulatory uncertainty. The EPA has announced that they will be sharing and releasing new rules for specifically designed for recycling as we think about the volume of end-of-life batteries that will be coming offline in the near future. And then finally, safety. There have been, unfortunately, many incidents where lithium-ion batteries, as they are transported, they are volatile and hazardous material. They do catch on fire, and unfortunately, it's a big issue for our industry as we look to solve this problem. I'll share with you here. This is basically the process that we here at Blue Whale Materials are bringing online. What distinguishes our process from the traditional use of water to discharge batteries, we've come up with a process that mechanically discharges these batteries. We've taken a process traditionally that takes a matter of weeks, 2 weeks, to submerge and dunk batteries under a saline solution, then bring them out and dry them, air dry them for shredding and processing. We've taken that amount and reduced it to a matter of hours. That's our proprietary technology that we'll bring. We then take that discharged battery, we process it, we shred it, and then we go through a process where we separate the metals from one another and create that black sand. That's our intermediary product that has a very high concentration of those metals. And in our process, we're able to separate the impurities, the organics, the other material that impede the next step of recycling, which is refining, to help separate those metals from one another. And then finally, to address this logistics and infrastructure nightmare that we currently are partake in the US, we plan to not only expand our processing plants in the US, but also to create collection centers. So our mission is to really provide regional processing of these batteries, as well as establish localized, if I could use that term, collection centers, where we'll be able to collect these end-of-life batteries, both consumer and EV. We'll be able to test them and find the modules that are still very high quality, very efficient, that can be then used in a secondary market where they're for secondary use. There is a lot of discussions about EV car packs eventually becoming energy storage systems that families can take camping. There was a wonderful program in Japan where they took these modules from car packs and then connected them to solar panels and used them to light up these lighting structures on the highway. So there's many different uses that we can then continue to recycle and use the good batteries for different applications. So in these collection centers, we will dismantle these car packs. We will test, recondition those batteries that can be continued to be used in other applications, but then also take those batteries that are inefficient and then move them for recycling. So again, creating an infrastructure that reduces the logistics costs, that also identifies batteries that can be used in secondary use is, we believe, the solution to provide an efficient and low-cost solution for the recycling industry to come. We'll be building out our first facility in commercial scale in Bartlesville, Oklahoma. We'll be coming operational at the end of this year in 2024. We're excited about coming online, but then also very excited about our acquisition of the testing and evaluation capabilities that we did in 2023 that provides us the expertise, again, to identify good batteries that can be continued to use in a different secondary life. So just to conclude, as we all know, batteries will penetrate every aspect of our lives. They are growing. We have projections of millions and millions of batteries that will be produced in the US. There is a desperate need to increase our recycling capabilities here in the US so that we can create an alternative supply of these metals that are critical into going back and manufacturing new batteries. This is very important, not only for our environment, not only for our safety regulations, but to help us in this electrified economy. And ultimately, it's become a national security issue so that we can cut our dependence on foreign countries like China, where they are able to dictate this economy, which puts us at a very weak position. And so we believe that recycling will really come online and be able to create that alternative supply of material to cut that dependence on that foreign entity. Thank you so much, and I'm open for any questions and comments. Thank you.
Robert, thank you again. The topic of battery recycling is definitely key in the formulation of the plan for electrification, because it is essential to have the full closed loop solution when you are thinking about electrification. So thank you for educating us. There is a question that has come up, and I will bring it to the forefront. What are your thoughts on the future recycling industry for lithium iron phosphate? Will it ever be profitable?
Yes, iron phosphate batteries, they can be recycled. I'll share with you earlier on in the industry of recycling lithium-ion batteries, maybe about 5 years ago, companies were paying for batteries to be recycled. I believe that's where iron phosphate batteries will begin. There will be a fee for the processing of those batteries. The processing technology is no different from lithium-ion batteries. It's just a matter of if we're able to extract some profit from it. I think that all also depends on the lithium, the price of lithium. Last year, lithium reached an all-time high in the price of its commodity, and so your ability to extract lithium from iron phosphate batteries, made it a very profitable recycling process. I think as lithium commodity pricing recovers, I think there will be some added benefit to processing iron phosphate batteries. So that, and then again, with innovation, with processing, We as a company are always engaged in R&D efforts to make this process more efficient, more economically viable. So I do believe iron phosphate, lithium iron phosphate batteries will become profitable to recycle in the future.
Great, great. There are other questions coming in, and we do have time for questions. So feel free to use the Q&A tab and enter your questions. I guess one of the big questions for me are, what are the next big steps here in North America to tackle some of the hurdles that you had mentioned during your presentation?
Well, I think one key aspect that is really injecting capital into the industry is the Department of Energy has identified about $3 billion to jumpstart this industry. I think so. You're going to have to see capabilities come online, as we addressed earlier, more companies that are able to come in to operate, but then also from recycling. It's the hydrometallurgical refining. So those facilities are coming online today. There is not a commercial scale facility that is operating today. We hope that will come on later this year, maybe next year, as those capabilities are refined. And again, what's necessary is to get that purity of those metals so that they can be put back into manufacturing new batteries. As battery manufacturing gigafactories come online here in the US, you'll start to see that closed loop, and we'll just start to see that become a viable closed loop here in the US. And again, it's about, in my opinion, it's about using logistics infrastructure in other industries and then showing them that they can be profitable and that this is a good business to come in and take the expertise, the experience of operating in other industries, bringing them into collecting lithium-ion batteries, which I think will be the key for the future. Everyone, I'm in this industry, and I think all of us would say we all have drawers full of old electronics that have these batteries. We just don't have a solution, a viable and convenient solution, let's be very frank, in how to collect them. I think those types of processes need to come online, and that will really spur and address a lot of the issues that we face today.
Great, great. Thank you for answering that. There are questions that are very similar in nature, and I guess I could summarize a few of them. It's revolving around the capabilities of BWM to recycle more than just lithium. That's number one. And then number two is, with all the different chemistries coming online, could technology have the capabilities of handling all that upstart of introduction of different chemistries?
Yes, yes, absolutely. So again, we are engaged in a lot of different R&D projects to ensure that our technology continues to advance. I'll share with you, for example, solid state batteries. Everyone is really looking forward to solid state batteries because the issue of a thermal event will be eliminated, right? We have the capabilities, our process today, we're able to process solid state batteries. So we're looking forward to that. That will take, eliminate that thermal risk, which we take very seriously. But as chemistries change, there is a lot of work you can imagine to get, again, more efficiency, more power, more density. So as OEMs, battery manufacturers are changing, we too need to keep innovating. That's why I think our acquisition of that testing and certification company, because that gives us, we test and certify new chemistries, new batteries that are coming into the market. So that really gives us a preview of what's coming in, and then will prepare us to come up with processes that can then address those different chemistries. But if I could just share this, I think the issue with everyone's concerned about new chemistries and your processes not being able to innovate and take care of those new chemistries. I would say while there's a lot of work to be done, and OEMs and manufacturers are going into that work, I think the chemistries of that of iron phosphate, of that lithium, with cobalt and nickel will remain. There's been a lot of work into understanding the safety concerns, right? The mixture of those batteries. And so again, there's a lot of innovation and research being done to other chemistries, but what we're seeing is, the lithium-ion, nickel, cobalt, manganese, chemistry is here to stay. Most of those gigafactories that are being built today, I believe there are about 350 worldwide of these gigafactories either being built or contracted to be built, are all on these chemistries. So I think this chemistry is here to stay. Obviously, different levels of metals to get that efficiency, but we'll see this stay for quite some time.
Great, great. Alongside with that, are you working with academia? I know you had mentioned DOE, EPA, but academia, getting them involved, and then there's also a follow up to that is how could industrial policy from federal and state level assist in supply side problems, right?
Yeah, absolutely. I think DOE has kind of led this way in academia. They are working with and providing grants and opportunities for schools, colleges to come in and to provide research and be really leading in these efforts. Yes, we are engaged actually with a university. I can't share with who because of the confidentiality of our projects, but we do engage with them, and we try to stay abreast, again, of new technologies, new innovations that will really alter our industry, which is so vital and so young, right? I think that's so important, that innovation leads the way in terms of this industry kind of growing and becoming more of a prominent solution for our country. And Rod, remind me of the second question, part of that question.
So the other part of the question was the industrial policy, federal,
Yes.
state level.
Can I share with you that some of the regulations that are out there today with the EPA were written about 30 years ago to address other types of issues that our environment faced. And so I think there is a lot of work being done. As I mentioned, the EPA has announced that they will come out. They're reviewing lithium-ion batteries. We've had a problem with trying to fit lithium-ion battery, the issues around lithium-ion battery technology with different regulations in different states. And there's interpretations that go along. And it's because some of these regulations have been in place for many decades. So I think there will need to be an evolution of these regulations that are vitally important. The Department of Transportation, in the next several years, they will see millions of car packs that are at end of life being transported in our highways. My family will be driving next to trailers full of end-of-life car packs that are being transported to be recycled. Those issues, the volatility, all of those issues need to be addressed. They are being addressed, and I'm happy to say that the EPA, they're engaging with operators like us to understand our experiences, our understanding of batteries, technologies, the serious issues that we face. And so together, I hope and believe that regulations will come about that keep our communities safe, but then also guide this industry, this important industry of recycling, to properly grow and become a solution for the US. Vitally important, and that work, yes, is being done. Not fast enough. We wish it were faster, but again, this is an issue not only for us domestically, but globally, because battery recycling, we receive a lot, as much as the batteries that we've been sending to Asia to be recycled, we also receive batteries from Europe, from South America that are coming to the US. And so, and I'll share with you, because of interpretations of UN regulations and guidelines, again, that were written years ago, not having lithium-ion batteries in mind, there is confusion. There is a difference in the way that countries define batteries, whether they're universal waste, hazardous waste, and so forth. So it is unfortunate today that those barriers exist, but I do hope and believe that different agencies, global organizations like the UN are taking a look at this and trying to streamline the understanding and definitions so that we can, again, address this issue in a more expedited way.
Yeah, so that's a really good point because regulation does set the precedence for the industry, whether it be because there was a question about establishment of collection centers is good, but how does industry plan to coordinate with auto shops manufacturers and whatnot? Regulation would solve that because it'll set the baseline and structure in how to collect, how to move product, how to recycle responsibly, right?
Yes.
So appreciate that response. There's
And
another question that, oh,
Rod, can
sorry.
I just add to that? No, no, no.
Yeah,
I
sure.
think it's so interesting because when you compare the U.S. to the EU, for example, the EU, it's estimated that they collect maybe 40 to 60% of the household end-of-life consumer batteries. That's amazing that they're able to do that. But again, it comes down to regulation, right? The
Correct.
EU is much more regulated than the US. And I think in the US, as a business operator, we don't want too much regulation. We understand it's necessary to keep our communities safe. But what I would say is despite the regulations in the EU, we have them as an example that collection can occur. There are methods to do so. So this, if I could put it this way, even with the lack of regulation in the U.S., which I think our society, we capitalize on that because of the lack of regulation. We still can, grow this industry and learn from our partners abroad in the techniques and ways that they're able to collect.
Interesting. Interesting. Yeah, that's a good perspective because this does pose the question of regionality because it is not different. It is not the same from region to region because of regulation, because of maturity of manufacturing of batteries, right? I think we had a session prior to this where I mentioned that there's there the origins of a lot of the lithium ion battery production, like the manufacturing, right, is not housed in the US, right? It's starting to come online. And that's why I think it is essential that we consider the dynamics of a closed loop system, right? But it does lead me to one of the other questions on the in this session that somebody stated, and this is, I guess, personal to me because my background started out in IT products, so consumer products. I used to work at Motorola designing cell phones. So electrification and lithium-ion battery technology is actually not that new in the consumer world. I mean, it started early 2000, late 90s, early 2000s in the consumer world. So I guess if you could touch base and address what's happening with that with respect to battery recycling, and is that a uh, is that a starting point to lean on, or is it something that we have to really reflect back and maybe you could touch base. Is it a scale issue? Is it something that is factors?
You mean in terms of electronics recycling?
Yeah, yeah. So no, because I mean, take cell phones, take laptops. They have lithium-ion batteries.
Yes,
Those,
yes.
I mean, you mentioned it earlier. There's products that we have that's been sitting in our desks or in our drawers for years, but what's being addressed on the consumer side, because that does play in, and that's a mature market in battery in battery usage, and
Yes.
particularly lithium.
Well, absolutely. And so again, I think we all know that batteries are, I want to say, invading every aspect of our lives, right? From our toothbrushes. I've seen lithium-ion battery powered hair dryers. I'm not sure why you need that, but we have them. So they're coming into every aspect. The problem, Rod, here is as they do so, I think it's providing convenience to our lives. But with the proliferation of the adoption of these batteries, we are then creating, right, hazards for our lives as well. And that's why we need to process them correctly. But think of it this way, as you're mentioning, with all these consumer, I don't know if anyone remembers early on when Samsung made their phones, you could actually take out the battery from the phone,
Correct.
right? And they gave you two batteries, one to
Correct.
charge and to swap in and out. That would have been phenomenal for us as recyclers today, but that's not the case. They ceased that. These batteries are embedded into these products. And so you have the challenge, and I think that's what you're addressing here, Rod. We have another challenge of taking these batteries out of these products. And I'll say what's just so innovative and I love about the industry is that you're seeing different operators come online that are able to, take these consumer products apart, recycle the glass, the aluminum, the plastics, and then now here we come with batteries. And so we're able to do that. But again, if I can add another wrinkle to this process, it needs to be a secure process. And what I mean by security is data. So I have a drawer of about 6 Blackberries that I used to use. I don't have the power cord for them, but I'm waiting for a secure way to recycle them. I can take them to my local store that has a box to drop in, for e-waste processing. As easy as for me to take it there and drop, someone also could come and pick up that product, my phone, take it back, who are much smarter than me, take the data from my phone, and then, unfortunately, use that for their own benefit. So not only do we have the challenge of separating these materials from one another, excuse me, collecting them, then separating, but it also must be done in a secure way. So I just share about all these issues to say there's a lot of work to do to establish this infrastructure to collect, and which is desperately needed so that we can properly process these consumer electronics that we are using and have become such an important part of our lives.
Great. I think you touched several aspects above and beyond what the question was actually asking, but appreciate the response. And yeah, that's pretty much all the questions. I think we've addressed all of them. So if the audience, if you do have any more questions, please add them to the Q&A tab on the top right of your screen. But yeah, Robert, I definitely appreciate the openness and the challenge that we have ahead of us, because you're right, the proliferation of batteries are entering every aspect of our lives. Right now, I'm on a laptop that is powered by a lithium-ion battery. We're on cell phones that are lithium-ion battery. Everything from the transition to carbon neutrality has some form of battery, right?
Correct.
So we're trying to tackle a large issue, but there's a lot of hurdles. There's a lot of hurdles ahead of us. But I think,
Rod, could I just address something that Krish asked here? I just saw his question, and I think it's so interesting, and it's a big topic to understand. And his question centers around auto shops, OEMs like
Yep.
Ford, GM, who, what's going on in the industry today is everyone sees value in these. Let's think about an EV, the battery, right? The issue has been lowering the cost of manufacturing these batteries, so that the adoption of EVs can continue to grow, and which will impact our environment in the future. The issue here has been, because these batteries are so valuable, there is, and I think that's what Krish is getting into in the question, there is going to be a competition for who controls these batteries. And let me share with you, from an OEM perspective, yes, they want to control and get that battery back. The issue here is, when I buy a car, an EV from Ford, my relationship is not with Ford, the company. It's with the dealership that sold me the Ford battery. And so the dealerships as well, they see value in these batteries. They are my first, connection to the EV. They will want that battery back, right? And then when you think about the used car market, where used cars end up in our society, they end up in auctions where they are auctioned off to scrap traders, right? Auto recyclers that take them apart. They will have access to a bunch of these batteries. Eventually, as used cars also make their way down south, meaning to South America, Latin America, you'll start to see batteries there. So I think the point of Krish's question is so important. How will we work with all of these stakeholders who want that value? They want to monetize on this. There is a lot of discussions now, and with each of these stakeholders trying to, catch their own piece of the pie, if I could say, to monetize on this. So I think, but through that competition, and that's what makes our country and our system so great. I think through that competition, you will see solutions come up and rise up.
That's a good avenue and angle that you took that question, because I related that back to regulation and how the industry coordinates. But you took it at a different angle, which I appreciate. There is one more question, and it's related to scale of battery recycling. So, what's the largest battery system that blue whale could support for recycling, right? Because there's now
So
discussions about megawatt hour battery systems for e-aviation or large construction equipment and the like. So I guess that's a good question.
yeah, I mean, for us, it's really when you're dealing with the same chemistries or similar chemistries, it's about size. So, we are able to take entire car packs and put them through our process without dismantling them. I think we do dismantle them because we want to test the modules within a car pack. So for those that may not know, in a traditional car pack, you can have anywhere from 10 to 15 different modules, right? And these modules are literally made up of cells that are very similar to our phones, those same cells, but stacked upon each other to create a module. Those modules are put together to create that density, right? And so we would dismantle them and to find the good modules to put them to secondary use. But there are new car packs that are coming out where these cells are all glued together. For example, Tesla takes that practice, and so we're able to then take that entire car pack and recycle it. As these batteries get bigger for energy storage systems, containerized systems, we would have to dismantle them. And again, it's a similar process and structure. These modules that are put together at larger scale. So there will be an aspect of dismantling, as well as increasing the size of our recycling capabilities.
Great, great. Appreciate the time. I think we've touched base on every aspect from the question and answer standpoint, but I do appreciate the time and the educational piece of the recycling aspect, because that is a big elephant in the room where we have to address globally, right? We discuss regional differentiations, but it's a global issue that has to be addressed if we do move down the path. And I believe we are moving down the path of battery electric vehicles, whether it be automotive or construction, and the likes, right? It is moving down that path. We're seeing it in the forefront of the public arena, right? It's being discussed from the regulatory environmental bodies as well as from the manufacturing and component level suppliers. So I appreciate the time. I, I, I encourage everyone, if there are any more further questions, to reach out to Robert at Blue Oil Materials to get more insights about the battery recycling community as it relates to regional perspectives and whatnot. And just a reminder that this session will be available once we finish. So if you need to refer back to it on demand, it will be available. So again, thank you so much, Robert. I appreciate the time. Well, actually, one more question came in. Thoughts on growth to even more nascent countries? You mentioned Central or South America or Latin America,
Yes.
right?
Yes, Krish, I'll share with you. Even today, we are speaking with collectors down in South America. They are seeing an abundance of batteries there that they're able to collect and properly dismantle. And so we are seeing a small but growing volume of these batteries. You know, the life cycle of even phones, different kinds of consumer electronics. Some end up in our landfills, unfortunately. Some will end up in our recycling facilities. Some also make their way down in these secondary markets and so forth. So they end up moving, you know, down south. And so these more nation countries, yes, they see a lot of supply. I think, you know, where you know, again, where there's an ability to make money, I think, you know, we find a way to do so. And so these countries are seeing value. You know, from buyers like us that want to partake. I think, will we go down and operate, you know, in other countries if the need arises? I believe so. But Krish, for us, you know, for example, Europe is a big industry and opportunity for battery recycling. Why? Because manufacturing really kind of went to Europe from Asia, right? In the Eastern Bloc, in these countries where it was economically viable, and so they seem to be ahead. They have the regulations to collect, and so the economic viability is there to operate. For us to go there, we are looking for partners because you know, we're an American company. We don't understand you know, or have the context or experience of operating in these foreign countries. So I think with the right partnerships, we will do so. But I also think it's about sharing technology, licensing our processes that may expedite that adoption in other countries. But yes, I think there is a lot of opportunity, which is why there's a lot of significant interest in this industry, because we are just starting, batteries are proliferating, and there's just like, as it brings convenience to our lives, there's also a desperate need to process them and take care of the hazardous nature of these batteries.
Thank you again, Robert. I believe if there are no more questions, everybody, thank you so much for participating. Again, Robert, thank you for educating the community here that has listened to your session. It's definitely something that we need to tackle, but I'm glad that you guys are taking all the necessary steps to come with solutions. So we look forward to seeing them in the future.
Thanks so much for the opportunity and hope this was helpful. Thank you, everyone.
Thank you.